Hello everyone. In this video, we will work on number 15.3 in the second section of chapter 8, finding the Taylor series for the function log x at the point 3. The first step is to write down the formula, right? In this particular case, x0 seems to be 3, so we need to plug in the numbers here. And then the remaining part is to derive a general formula for the case order derivative. In particular, for k greater or equal to 1. Right? That is because whenever k equal to 0, this is basically the function evaluation. Right? f3 equal to log 3. This is straightforward. Okay, and then we need to find the higher order derivative. Right? So first order, second order, third, and fourth. Right? We can do a few experiments. Right? Just write down their derivative as much as you can. Right? Normally is 4 or 5 terms should be enough, right? Getting their derivative and then evaluate at the point 3, right? We will get these values. All right. Now the point is based on the existing numbers we have here, can we be able to get a pattern for the case order derivative evaluate at the point 3? Okay. Now take a close look at the numbers we have seen there. It seems that we have positive, negative, negative, all right? So we do have a terminating in terms of sign, so it makes sense to have a term like this, -1 to the certain power, right? We just need to check just some modification. We can see the component will be k minus 1, all right? When k equal to 1, we have positive. When k equal to 2, we have negative, all right? Now, the remaining part will be a ratio like this one. The denominator sounds straightforward, right? It should be 3 to the power of the order of the derivative that we take. All right, so that's 3 to the power of k. Now numerator, if we look at closely, right, you can say 1 here, 2 here, 6. All right, so all these can be written as, like you can see, it's 1 factorial, 2 factorial, 3 factorial. All right, so this is actually the k minus 1 factorial function. Okay, in general, this one is more involved because we need to figure out a pattern based on this. And we can make this procedure to be more rigorous by introducing the mathematical induction procedure. However, I really think just based on inspections, we can still figure out the patterns. Okay, all right, so now we can plug in the values we found here to have this. Don't forget that this is just a case order derivative here. In the formula part, we got to divide by k factorial. All right, so we will still have this term, and then there will be some cancellation. And then finally, we will obtain a term like this. All right. However, in your homework, if you stop here, I think that will still can't collect. Okay. Finally, let's do a quick recap. For a problem like this one, there are not too much that we can do, right? First, write down a formula, specify the value of x0. All right, the next step is to compute the higher order derivative, for example, up to 4th order, 5th order, compute the derivative function, evaluate at that particular point. All right, the most challenging part will be based on the first four derivatives. Can we guess a pattern of this general derivative here? All right. If we are able to get a formula like this one, the remaining part is just to plug in, and then we don't even need to simplify it. Okay. So this is what we need to do here. Thanks for watching.